What's up, everybody? I'm gonna make a quick video about the sensing homework this week. Just to make sure you guys know somewhat how to do the coding portion of it, which involves plotting your v out over v in, your transfer function um, of your filter. So I'll go into it a little bit here. So we're using NumPy and Matplotlib. That's it. And then we'll skip the function part for now. So right here, so first whatever design I have, right, it can be, whatever design you have. This design in particular, which again might not be right. I'm using R1 as a 10k ohm and R2 as a 10k ohm, which you just don't do that. And then C1 and C2, I'm stating the capacitance of them. Whatever this is, so this is your design. This is what you're designing for. So then I create a frequency range using np.log space. This is just like a time array, but it's just for frequencies that goes from 10 hertz to 100 kilohertz. And then here's where the function I made up here comes in. So this function first takes in the frequency, which is what you're trying to calculate it for. Your model values, the values of your model, and then it calculates omega, which is the squiggly W and like the JW stuff. So that's the frequency, right? And then S is I don't know if you guys have seen. You guys might not have seen S yet before, but this is just the imaginary part of the frequency, or just the imaginary part. So because that's what we're focused on when we talk about frequency. So basically, what we're doing is in this equation here. That's like this is V out versus V in, but just simplified, and the W's are replaced with S's, basically. And then here is the equation for gain. So that's something that's, you can either figure out yourself or they're in the lecture notes. But yep. So now that we did do that, we calculated it, and I'll have the same size as frequency, right? Because that's what we're passing in. And then we just plot it. Now note that I'm using plot.semilog x to plot in like log, and then remember when you find the magnitude in decibels, you have to do this. So np.log 10 np.apps h times 20, and then for the phase response, that's also very similar, except you're just using np.angle instead of np.log np.apps, and then you'll get something like this. Now remember, designs will be different. What the sigma? Alright. Thanks.